Now in real time, the object which is crossing the center point, we have this circle, has the color detector. So for example, we have now this orange, which is between yellow and orange. You can see all this. Hi, welcome to this new video. My name is Sergio, I'm a computer vision developer and consultant, and I help companies, freelancers, and students to easily and efficiently build computer vision projects. Today we will see color recognition, so how to recognize a specific color in real time from a webcam. And we're going to see this in 3 steps. At the beginning of the first step, you are going to learn the difference between the HSV color format and the BGR color format. On the second step, you are going to learn how to define the ranges to detect different colors. So if it's orange color, if it's blue, if it's gray, and other colors that I have somewhere here around, like most of the primary secondary colors. And then on the third step, you're going to learn how to apply this in real time from your webcam. So you will be passing an object in front of the webcam, and the program will tell you what color is that specific object. So let's start. We're going to use the Opencv library and we're going to write the code in Python. So if you are new to computer vision and you don't have Opencv, you need to install the Opencv with the command. So first of all, you open the terminal, whether you are on Linux, Mac, or Windows, it works the same way. You just type pip install Opencv-Python, and then you press enter. If you have Ubuntu, most likely if you're using Python 3, you need to install using pip3 instead of just pip. All the code that I'm using right now and more information are on the blog post below. So if you want to download, it's for free. You click on the blog post below and you will find the download button and all the text we've written, the information, the article about this video. And now let's start importing Opencv. So import cv2. To understand the concept of the colors, we're going now to load some samples images. So img equals cv2.imread. So we're going to load some image, blue.jpg. So let me make sure that I have this image here somewhere. Blue background.jpg. Blue background.jpg. And then cv2.imshow. Let's show now this image. emg, and then emg cv2.wait keep. We need a wait key event to keep the image open on hold, otherwise the code executes and it closes. So now we can just run this one, and we have now a blue image. That's just a blue background. What color format uses Opencv and how does this work? It's very simple. This image, which is size, I'm not sure, it should be 1000 by 1000 pixels, is drawn with the BGR color format. So each single pixel has 3 values. If I print this image, print emg, of course now we have we cannot display all the input, but we will have 1000 columns if I will print everything. So 1000 pixels on the width, so on the x-axis, and then 1000 on the y, so 1000 columns and 1000 rows. And it uses the BGR format. So the first one is the blue color, the second is the green, and the third is the red. And the scale goes from 0, that is the absence of that color, to 255, which is the maximum of the color, and it's the same for each of them. So different colors are the mixture of the 3 primary colors. So it's pretty similar to what we have in real life. If you mix the blue with the red, you have one color. If you mix the red with the green, and so on. Or if you mix all of them at the same time with different gradients. In this case, you will see that this is blue because we have from the scale 0 to 255, we have 154 of blue, we have no green, and we have only one of red, which is almost like we have no red. To prove you this, let's try with a different image. I have also some other colors. Say I have orange, or I have red. So let's load red.jpg. And you can see this is red, and we have 33 of blue, 26 of green, and 237 of red. Then I have also orange somewhere, orange background.webbp. On .webbp, let me load this one. Stop and run. So I have orange. Okay, I did some mistake with the title, so I didn't get the path correctly. Orange background.webbp, so this should be correct. The orange, in this case, the mixture of red, so almost the maximum of red, and some of green, so some only 94 of green from 0 to 255. Of course, these are images where each pixel has the same value. We can have, of course, in real life, it doesn't work that way. If I take this orange, of course, each single pixel of this orange is different. And so, just to give you an idea, let's take some other image. I have oranges fruit, .jpg. So if I load this one, you will see now that each single pixel has a different values. Of course, they are really similar together because most of the value of this on this image are orange. Maybe some is darker, some is lighter, and so on. Now, this is the BGR format. When working in a real life scenarios, the BGR format doesn't work well. And let me give you an example. And to understand why we can't use the BGR format in real life, I'm going to use the color picker from GIMP. So you don't need this. So this is the GIMP, the free software, free image manipulation software. And I'm using this because it has a nice color picker which can explain easily how this works. Here we have RGB and HSV at the same time. So RGB is exactly the same that I just displayed. Now let's focus only on RGB. In Opencv is BGR, but it's the same. It's just the order is different, but it's exactly the same. 3 channels, red, green, and blue. This is the color that we have right now. Okay, sorry, this is the color. So we have current color, this one. Now it's black because we have absence, we have 0, 0, 0. We have 0 of each color. If I want red, here I can put different gradients of red. So it's with a low value, it will be a dark red. With a higher value, it will be a bright red, till the maximum, where it is 255, and that is what we get. The same is for the green, dark and bright, and the same is for the blue. Now, what is the problem when we want to pick a specific color using the RGB format? The problem is that each single color is the mixture of these 3 primary colors. And so sometimes when there is just some lightning change, let me pick this violet right here. Now we have almost no green, only 18 of green, 163 of red, and 173 of blue. If I change a bit this color, all of them are changing. All the primary colors do change if I focus on this specific color. It's similar, but all of them are changing the ranges. And so if you work with this in real life, also just some lightning change might affect the program and you might miss completely the recognition. That's why there is a second color format which suits better our goal today, and this is the HSV color format. HSV, which stands for hue, saturation, and value. Hue is the color that we want. So on hue already we can pick different colors. Now to make things simple, let's do this. Hue has a value in this case from 0 to 360. Here, if we have the red, it will be at the beginning of the scale. Then we have red away orange, yellow, green, cyan, like blue, darker blue, violet, pink, and red. So already the hue gives us the different color without doing much mixture of the rest. While the other two values are the saturation is the quantity of that color. So 100 is the maximum, and 0, of course, there is nothing, so 0 will be white, you can see. And then the value is the brightness, so how bright or how dark is the color, where 100 is the maximum of the color, and this is the minimum of the color. I hope that you're following, because that's really important to understand. To make things simple on Opencv, I also created a code. It's a very simple code that you can download below. It's called, when you download the code from the link below, there will be a zip file where it's everything included inside. And this specific file is called HSV color picker. So you run this code, hsvcolorpicker.py, and that's what we have. We have three values, HSV. And we can play around with the trackbar with these three values. On the H, we change the color, as I am doing right now. And on the saturation, okay, on this S, we change saturation, and here we change the value. So with this color picker, we can understand the ranges that we can use to understand the colors in real life with Opencv. And keep in mind that Opencv has different ranges, so each program uses different ranges. For example, the GIMP uses from 0 to 360, from 0 to 100, 0 to 100. Here we have from 0 to 179, 0 to 255, 0 to 255. Don't get caught up, stuck in the ranges. It's just a different scale. Like on the grades, some country uses from 0 to 10, some use the letter, some from 0 to 100. It doesn't matter. We have minimum and maximum, and different gradients on the middle. That was the first step necessary to understand how colors work in computer vision, especially Opencv. Now let's create our color picker in real time. How do we do that? Let's code everything from scratch. What we are going to do right now is we are going to take a frame from the webcam, and so that we can test in real time our code. We import CV2. Now let's load the camera. Cap equals cv2.video capture 0. 0 is for the first webcam, 1 for the second. So if you have multiple webcams, you can just change the index to change the webcam. Now let's get a frame. Underscore frame equals cap.read. Once we get the frame, we need to show it on the screen if you want to see it. So cv2.imShow frame, and then frame. So what do we want to display? We want to display frame like this. And now a wait key event to keep the image on hold. cv2.wait key 0, and let's run this one. Let's stop and rerun. Right now we got a frame, so we are already at the beginning, a good step. Now let's check from, let's put this in real time, of course, because we're working with the camera. There is no point just to have a stable frame. And let's do that. So we get the frame. Here we're just getting one frame. What is a video? What is the difference from an image and a video? A video is nothing more than image after image. So if we want to get the stream in real time, we simply can put frame in a loop. So while true, and everything that is here in a loop. So it takes the frame, we show the frame, we display the frame, and then we go to the next frame and so on. Now we don't want to freeze this anymore, so let's put wait key 1 so that it doesn't wait for us to press a key, but it waits 1 millisecond, and if we don't press a key, it goes to the next one. If we press a key, we will have an output. Here, when we press a key, here there will be a value for key. If the key is 27, 27 will be the S key on the keyboard. We want to break, so if we press the S key, it quits. Once we quit, we want to release the camera cap.release, and also we want to close all the windows. So cv2.destroy all windows. And now let's run this one. Okay. Now, ideally, my idea is to make things simple. We cannot take the entire image. That will make some complexity, and that's not what we want right now. Instead, I want to take only one single pixel, and I want to display the value of that single pixel. And the pixel will be exactly at the center of the screen. Somewhere here will be the pixel. Also, I want to increase the what's called the size of the frame, the resolution, because it's too small. Like, let's put at least HD. So cap.set cv2.cap prop frame width, and this is the width. We're going to put HD, so HD is 1280 of width, and it will be 720 of height. 720. So this is HD standard sizes. We have full HD which will be 1080 by 1920, 4K and so on. That's HD for now. It's more than enough. So 1280 and 720, and let's now take the center. We want to take a specific center point of the screen, so we will focus only on that one. How do we get the center? We can divide the width divided by 2, we have the center X. Height divided by 2, we have the center Y. First of all, let's get in real time the width and the height. So height width underscore equals frame dot shape. The height, let's get center X equals width divided by 2, and center Y equals height divided by 2. Let's make sure that they are integers so we don't get any error, because the pixels in Opencv, they always need to be integers. You will see now here on the bottom left, the output of the specific pixel right there. So when I put this orange, ideally, and we see that it has a lot of red, some green, because here it's the mixture of red and green, and it has a little bit of blue. When I put this blue, you can see that on the values, the blue has 255, close to the maximum. Then we have a bit of green, and we have almost no red. And this is the beginning. So we're just using now the BGR format for this, which is not optimal. We need to work, as explained before, and explain also why, with the HSV color format. And so we cannot just take the frame right away, but we need to convert the frame into HSV. HSV frame equals cv2.cvt color. We want to convert what? We want to convert the frame. And then cv2.color underscore. Now we need to say which color format we want to convert this from. Color BGR to HSV. By the way, this seems difficult, but it's not. So these are basic standard functions of Opencv, and once you know this, everything will be easy. You need just to master these few basic things of Opencv. If you want to know more about this, I have a full computer vision course where I explain all the basics step by step till creating more complex projects, also for beginners. So if you have no idea what this is, if you're just starting, you don't know where to start, that's the best course for you to understand everything and build your own projects. I will put also some links down below on the description if you want to know more about that. Now let's continue with this. We are converting the HSV frame from BGR to HSV. Now, instead of taking the pixel value from the frame, we're going to take the pixel value from HSV frame, because that's what matters for us. And it will be exactly the same now. I mean, it will be exactly the same process, like we will be printing now the values, but instead of printing the values in BGR, we're going to print them into HSV. And now let's only focus on the value at the left side, which is the H, which we have 22. And this is one of, now we are close to the end, I will say, because from now on it will be very easy. How can we now select the different colors? To select different colors, we can just define color ranges. So where does a color begin, where does a specific color ends, and so on. And for this, that's why I created the color picker, to make things very simple. I will put just few basic colors, and then you can play around with this and you can put your own colors. And let's run this one, run HSV color picker, so that we can understand the ranges. Now, we are going to use only the hue. Now we don't care about the saturation or the value, because the hue is what is defining for us the colors. Of course, we can use also them, but now it's something very basic, which will do a good job already. Let's now define the colors. From 0 to 6, from 0 to, I don't know, to 5, 4. From 0 to 4, we have the red. Let's say this. If, let's check this carefully. On color recognition, we are taking the pixel center. Pixel center has 3 values, HSV. Let's now take only the H. Hue, pixel, hue value, let's just take hue value, equals pixel center 0. So from the output that we had before, let me show you the output, if I can just, okay, I don't, right here. So this is the hue saturation value. We're going to take only the first value, hue. So that's why we put index 0. Now, how do we define the color? We can say if hue value is less than 4, or let's say less than 5, because 4 is included, then the color is, let's say, red. So we start with undefined color. Color is undefined. Then color is red. Now let's look at the picker. If from 5 to 22, from 5 to 21 is orange. If hue value is less than 22, color will be orange. And if hue value is less than, let's see which is the next, from 22 to 37, here is like Is this yellow or green? Like I can't really define. I guess the color are never objective. It might be a yellow or like some kind of green. Let's say until 33 and 32 is yellow and then it's green. So 33 is color equals yellow. Elif hue value is less than. Okay, I don't want to take a lot of time just taking this. I'm going to pause for a couple of minutes. I will put all the ranges and then we're going to test it. It will make more sense than just taking like few minutes just checking this. And here we have it. We have a few colors: red, orange, yellow, green, blue, violet, and then red again, because here the ranges starts with red, but also at the end we have the red. And probably let's increase a bit this one. Yeah, it's better. And now let's test it. So I'm going to display in real time the color. Above the circle, let's say cv2 dot put text, and we want to put the text where on the frame. Let's put the text just on the top left of the screen, and let's now put the color. So what do we want to put? We want to put the color. Where do we want to put the text? Let's say I just said the top left of the screen, so it starts with position 0, 0. Of course, I need to give some space from the top, so let's say position 10 and 50. Now the font, we don't really care about which font I use, so I'm going to go fast with this basic. So if you change 0, 1, 2, you have different type of fonts. I use 0, which is the first font, and then the size of the text 1, and the color, let's make it neutral color. Let's make it blue, and 0 and 0 and 2. Well, ideally we can use the same color. We could use the same color of the object. That would be nice. So let's use the same color. Instead of putting everything blue, let's get the color, pixel center, the BGR color of the object. Pixel center BGR equals frame and let's say I'm not sure if it works. We probably need to extract the color. I'm complicating this program with unnecessary steps, like with this color. Like I could make this more simple, but anyway, it will be more nice and maybe worth it to make it this way. Okay, my mistake. Yeah, I'm picking the pixel on the wrong way to give the color. So let's use now blue, and later I will just change that. Okay, so let's first make sure first that it works, and then we can make it nicer, not the opposite. So priority first. And okay, now we have red, which can make sense. There is some, my skin is the closer color between the one we have to my skin is the red. Now let's check the orange, and wow, it's already working well. We have between orange and yellow, which makes sense because with the lighting, so part of this is orange, part is yellow. I have some yellow object on the floor. Yellow, okay, nice. Let's check the blue. Wow, it's working great. And I don't have any other color with me right now to try. I don't have anything green, but I guess it works. Now let's just make it look nicer. So red, so I wanted to put the color that we are using, color red. pixel center BGR, let's extract BGR equals pixel center 0, pixel center BGR 1, pixel center BGR 2. So we need to extract the values and then use them right here, BGR. And we can do the same for also the circle that we are drawing. And let's say integer for each of them, int, and then int. And let's use this where we're going to use this right here. So on the text, B, G, R, and let's put this neutral color. Let's put it somehow black, or even completely black, or just almost black. 25, 25, 25. And maybe let's increase a bit the size of the text, 1.5. And the position to make it fit. So we're increasing the size, so we need to make some space. And let's run this one. And it's working really nicely. You can see how the color of the text above is adapting to this, and we have yellow, orange, and it's also understanding exactly what color is that. Let's use now the blue. You see, nice. And I hope that you enjoyed this tutorial. This was some really basic color picker recognition. Of course, you can pick only one specific pixel, but if you want a more advanced recognition using a bigger area, you should use more advanced methods, which will use the HSV format plus some machine learning with KNN or convolutional neural network using deep learning. And if you want to know more about color recognition, let me know in the comments, and I might bring a more advanced video regarding color recognition using neural networks. This is all for this video. Make sure that you subscribe to stay updated with new things that I'm going to release soon. And if you want more advanced stuff, you will find everything, all the links down below to access to my more advanced and premium sources. This is all for today. See you on the next video.